all the good stuff that goes along with it. So we're going to start this with stuff that you already know. Okay, so I'm going to slide this off to the side and say, tell me what you know about triangles.
Oh, I remember there's something like, there's like a 30, 60, 30 triangle, whatever it's called.
Ooh, okay. So there's such thing as a 30, 60, okay, so 30, 60, 90
there we go.
triangles, and then there's also 45, 45. So those are what are called your special triangles.
Right.
And they have super special relationships between the sides. We will definitely talk about that.
Isosceles.
Not today. There's isosceles triangles. Oh, ooh, should we write down what those mean? Does everybody remember?
Nope.
So what's an isosceles?
It's like everything is the same.
Two sides are the same. Two
All right.
equal sides. Oh, look at all your good words. Okay, hold on. Equilateral. Three equal sides. And scalene. Don't judge my spelling. I think that's right. No equal sides. Okay. Right triangles. Right triangles, so that's 90-degree angle. What's one that does not have a right angle? Ooh, obtuse would be one that has a an angle that's bigger than 90. And acute is everything is less than 90, right? What's that? What do you mean? A right-sided angle or a right angle? A right angle? Well, yeah, a right triangle has a 90 degree, which is a right, by definition, a right angle.
What was the question? I guess.
What is a triangle called that does not have a right angle?
Oh, I don't know.
Not specifically. Although an isosceles triangle would probably, well, you could potentially have a right angle with an isosceles. Oblique. Oblique. So oblique is a word you'll have to remember because we'll talk about how to solve oblique triangles. So no 90-degree angles.
Because I remember learning it last year about, it was like a special equation or something like that, like the 30, 60, there's always going to be a 90 or something like that.
Yeah.
You got to follow 180 degrees.
Ooh, okay. Wait. What'd you just say about 180 degrees?
All triangles are 180.
Yeah, they are. That's good to know. Okay, so interior angles, right? Angles equal 180. Sorry, I'm totally abbreviating this, so hopefully you're following me. Interior angles equal 180.
We did this in the very end of the year, but I just don't remember.
Right. Okay, so at the end of the year, you work specifically with what kind of triangles? Do you remember that? Specifically with, okay, yeah, there was special ones, but they were right. So let's talk about right triangles specifically.
There's Pythagorean theorem.
Yeah, there you go.
Sine, cosine, tangent.
So we got Pythagorean's theorem. Okay, so do you remember what Pythagorean's theorem is?
A squared plus b squared equals c.
Okay, good. If you did not know that or uncertain about it, write it down. You're going to be using that today.
And just leave now.
Good point.
Oh.
Okay, what else did you know about right angles? Right angled triangles, right triangles. Did you learn? Okay, the sine and the cosine and the tangent stuff, you remember that? Do you remember the little phrase that kind of correlates with it? Yeah, okay, write this down. So, ka, toa. You guys didn't learn this?
I don't know.
Okay, so when you go to take the ACT or any kind of collegiate test, I can guarantee there'll be stuff like this on there.
Oh, I
It
remember
always
this.
comes to this. Yeah, SOHCAHTOA. So, does anybody have a good acronym for this? SOHCAHTOA? SOHCAHTOA. Yeah, I mean that technically works, but that's like sounding it out, kind of. But like, the acronym that I was taught when I learned this not very long ago is some old hippie caught another hippie toking on acid. Toking.
Yes.
Which I never forgot. Although whether it's school appropriate or not, that's up to you. But I never forgot that. Some old hippie caught another hippie toking on acid. Oh, never mind. It's like puffing. All right, never mind. Sorry to go there. Anyways, what is do you remember what these stand for?
Sine is opposite over hypotenuse.
Okay.
Adjacent tangent.
Ooh, nice. Okay, so let's draw a triangle just so we know what you're talking about. So you're saying words like hypotenuse and opposite and adjacent. Well, what the heck are those things? So if you're working with a right triangle, the most obvious side to identify is the one that's the longest, which is always the hypotenuse.
That is the angle.
Okay, so which one is going to be the opposite side?
The one across.
The one like literally opposite of the angle. Like mathematicians are not creative, you guys. It is literal. So the adjacent means.
That's
Ooh,
right
here's
next
word
to-
clues. Did you guys know that adjacent means next to? Like if you look that up in the dictionary, it
See what's so
means
weird about
next
this?
to.
They don't look opposite or adjacent. They use, if you
It doesn't look opposite?
like
From this angle?
The
The side that is opposite of the angle?
Well, see, now that makes sense because once you draw it like that.
Oh, well that's what it means.
Yeah.
It's just the one.
No, so I was looking at the sides, not the angle. I was looking at
Oh.
how's the hypotenuse side opposite to the other side. I was like,
You have to go by
You have to go by the angles, right.
Off the angle, yeah. Majorly important. Okay, so then you said the SO stands for what?
opposite over.
Right, so it basically gives you this ratio. So it's the sine of the angle, which by the way, in our case, that angle, you guys have seen that symbol before, right? That symbol is just like an X. It just is a variable, but it is in reference to an angle. That's why it's curled like that. So what did you say, opposite over hypotenuse? Okay, so what's the ka? It's not a bird. Cosine of the angle is adjacent over hypotenuse. Is this new information to anyone?
no,
not new, but I don't remember.
Well,
it's not new. It's just you kind of remember.
okay, then get a tattoo and put this on your wrist. What is the TOA? Opposite over adjacent. And this is like, these two things right here, the Pythagorean theorem and the SOHCAHTOA, are things that I have actually used outside my educational world. So just so you know, if you happen to be building something, whether it be stairs or who knows what someday you're going to have to fix in your house, because someday you'll all be homeowners, I hope. And you'll be fixing something and you go, oh, here's this right triangle. How do I solve this again? And you'll be like, oh yeah, I remember Miss Nolte told me this.
It really helps.
It actually helped it.
Because there's a lot of questions about that.
Oh yeah, exactly. All right, so we'll do some examples of that here in a second. Can anybody else tell me something else you know about a triangle? Okay, maybe a little bit more complicated than that.
But that's like the most complex.
How about any formulas that you know about? triangles. Like the area. Okay. That's important. They always like to ask you, what's the area of a triangle? So that's one thing you're going to be doing today is 1/2 times base times height. What's that?
He has some weird demented gummy bears.
Oh, perfect. Can you tell me something specific about that formula, though? There's Were you going to ask a question?
No, I was going to talk about angles.
Oh, ooh. Okay, we're going to talk about that too. So pause on that thought. Back at this formula, is there little details that you need to know about that formula? Like what is the base, what is the height? Like, let me draw a picture of a triangle for you. Theoretically, I should be able to find the area of any triangle, right? Well, here's my triangle A, B, C. How do I find the area?
Well, you gotta find which one's the base.
Okay, let's say my base is going to be this right here. B. So by the way, when you're labeling triangles, just a quick, so you know, these side lengths are just literally opposite of their angles. Okay, so side A would exist opposite of angle A, and side C would exist opposite of side C. And they're lowercase letters, and angles exist as uppercase letters. Okay, so let's say my B is the base. We'll make that easy, right? The B is going to be the base. So what's my height then?
You have to find the right angle.
Oh, so you have to like do some math and stuff and like find the height? Oh, man, and it like has to be a right angle, right? Oh, okay, so let's do some math. Let's figure this out. Okay, so when I just drew that height, what happened here is I just drew a second triangle. Technically, there's 3 triangles there, but I want to look at that green one right there. Okay, and let's say I'm going to use my angle A, and I'm going to try to figure out what my H is. Okay, so what are the 2 sides that are involved in my green triangle? First of all, what are the letters that you see? C and not B, because B is the whole length of the base. So we can't use the B. C and H. C and H. See the green one? Okay, so if I'm going for my A, my angle A, which trig ratio am I going to use? What sides are those compared to my A? Opposite and adjacent. So what trig ratio is opposite, not adjacent, hypotenuse? I said, sorry, my bad. Opposite and hypotenuse. Hypotenuse. So which trig function is opposite and hypotenuse? The sine. So would you agree that this would be, let's see, the sine of angle A is equal to the opposite, which is H, over its hypotenuse, which is C. Would you all agree with that? Okay, so if I solve for H, how would you algebraically do that? Just simply multiply by the C, right? So would everybody agree that H is equal to C times the sine of A? Feel good about that? So, remember how we just said the area is 1/2 times the base times the height? Well, I know what the height is. What's the height? It's what? C times the sine of A. So I now have an equation that will work for any triangle given the side lengths. I don't have to find my height. I can use this equation instead. Okay, so write this down in your notes. The area of a triangle is 1/2 times B times C times the sine of A. Don't you love it when life is made easier by math? It's so cool. Okay, now let's go back to what Emily was talking about, and what were you, that thought bubble you had?
Alternate angles, like alternate interior angles.
Ooh, okay, I thought you were thinking about something else.
Side angles.
Ooh, side angle side stuff. That's what I thought you were talking about. So do you guys remember like side 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 and side angle side and angle side, and then there's the bad word that we don't talk about. Okay, and we'll talk about the bad word eventually, but not today. What scenario do we have right here? If we have the B, the C, and the A. Okay, do you see which side lengths we're talking about, or pieces of this triangle? We're talking about the C, we're talking about the A, we're talking about the B. What scenario is that? Side, angle, side. So here is a big piece of this area formula. We can only use it if we have a side, angle, side scenario. Okay, you ready to math? Even though we just kind of did, that was actually algebra, but let's actually do math now. Ready? Wrote it down, start it, put a highlighter on it. We'll do that later. Okay, moving off, everybody good? Okay. Ooh, you don't want to watch this good stuff? Oh, okay, hustle. All right, here is my first example for you. Oh, shucks.
Sorry. It's okay.
Okay, so write this down. Find the area of the triangle, and it says to the nearest tenth. My first question to you is, can we use the formula that we just found?
Yes.
We can. We have a side, angle, side scenario. So, what's my formula going to be? Or my equation, excuse me. 1/2 times... Yeah, so remember that the B and the C's are just the two side lengths. So it's just going to be the two sides getting multiplied together times the sine of the angle that's given. So in our case, 34. All right, everybody grab your calculator. This is an important thing I have to show you too. Now we did just do this in the last class, so it shouldn't be too big of an issue, but... Okay, so you know you're going to type in 1/2, I'm going to do 0.5 times 12 times 15. Did everybody find the sine button? The sine of 34. And did everybody get 50.3? Did anybody not get 50.3? Because it's possible for you to not get 50.3.
That's a calculator setting, isn't it?
It is a calculator setting. Okay, so one thing you have to be very careful about when you're working with sines and cosines and tangents is the calculator has two modes. Okay, everybody hit the mode button. You see this button right next to the blue key? Okay, the third one down is talking about angle measurements. Okay, there is such thing as a radian measure, which we will learn about, and there is such thing as a degree measure. Okay, so which one do you think we're using?
Degree.
We are in degrees. So the first thing that you need to do every time you sit down at your calculator is check your mode before you type this in, especially on a test. Make sure your calculator mode is in degrees. I'd hate for you to do an entire test in radian measure. Oh my gosh. Minus 100. Okay, so everybody got 50 points, what was it, 3? 3. And then we're talking about an area, so we need to label our measurements, our units. And in our case here, we've got millimeters, and area is squared, right? Do I need to do another example of finding the area of a triangle? That's pretty easy, right? As long as you have a side angle side, life is pretty simple. Okay, so moving on. Bless you. We're now going to work with solving right triangles. Okay, so today we are specifically working with right triangles when we are solving. We will eventually moving on to solving obliques, but today we're just doing our rights. Okay, so those two formulas that you will start in your notes, the Pythagorean's theorem and your SOHCAHTOA, that's what we're using to solve our right triangles. Okay. All right, which example should I do? Ooh, let's do this one. I haven't done this one yet. This looks like a great example. All right, so we've got a building, clearly, and it's casting a shadow that happens to be 33 meters. The angle of the sun is 27 degrees to the vertical of the building. And so we're going to try to figure out how tall the building is, and then we're going to figure out how tall or the length from the end of the shadow to the building is, and the angle off the ground. So no, we're not going to find the area. Is that what you're thinking of?
No,
Or are you thinking about something
different? Completely different.
Oh, yeah, okay, don't go there. Okay, so we have this triangle EFD, DEF, F, whatever you want to call it. But those three variables are involved. So we're going to find basically all of the missing pieces. So, anybody want to tell me a piece of this puzzle that would be super easy to find right off the top? Go ahead. Angle D, right? So if I have a right angle and I have a 27 degrees, we can easily find angle D and do 180 minus 90 minus 27, and we'd all agree that that is 63 degrees. So make sure, by the way, that since we are finding an angle, that you do label it as a degree. That's how I know if you are finding an angle or a side. All right, now what should we find? Let's see, we've got side E we need to find, and we need to find side D. So pick your poison. Or 50-50 here, E or D, D or E, D, D. All right, so D. So I'm always going to use given information in order to find new pieces of information. So I'm going to go off of my angle F. Okay, so if I have angle F, and I know that side F is 33, what two pieces of the triangle am I working with? Which two sides? There you go, you got it right this time. Opposite and adjacent. So which trig ratio is opposite and adjacent? Tangent. Okay, so we have a tangent of our angle of 27 degrees is equal to our opposite length, which happens to be 33, over D. Well, I'm not even looking at what they're asking me to do here. Let's just say we're going to solve the triangle. Sorry, I didn't even read that. Blah, 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 blah. How do I solve for the D? Multiply the D out, right? So we're going to have D times the tangent of 27, and then how do you solve for D from there? Divide, good. Divide by your tangent. So in the calculator, you're going to type in 33 divided by the tangent of 27. I'll let somebody do that for me. 7 to be exact. Okay, so we got a length again, so I'm going to label that in meters. Okay, what's my last piece I've got to find? The hypotenuse, my E. So how could I go about doing that? Okay, I could absolutely do a Pythagorean theorem, or I could do a trig ratio. Which one do you guys want to do? Should we do a Pythagorean theorem just for practice, since we just did a trig ratio? Doesn't matter which way we go. We'll get the same answer either way. So if we're looking for E, that's the hypotenuse, so that's the one I have to set it equal to. So it's going to be E squared is equal to the length of D, which we just found to be 64.77 squared plus 33 squared. Ooh, well, that one is pretty straightforward. So what is 64.77 squared plus 33 squared, and then square root it?
72.69.
72.69 meters. Okay, so there we go. We solved that triangle. Do you guys want me to do another example of solving triangles? What if, here's a quick example. I'm going to throw this off to the side because last period wasn't really sure about this. We'll just call this example 2. Let's pretend you're solving this triangle and we'll go A, B, C, and we're just going to find angle A, let's just say. And this length over here is 10, and this is over here is 15. Okay, so we're just going to find angle A. Find angle A. How would I do that? So which sides do I have? Just 2 sides. Opposite and hypotenuse. So its trig ratio is opposite and hypotenuse. Sine. So I would do the sine of angle A is equal to 10 over 15. How do I solve for A?
No, I'm not.
This is going to be...
Angle has its own correspondence.
Yeah. You're on the right track. You're thinking way harder than you need to. You're almost starting to think about like a unit circle and that type of scenario. But we'll get there. We're not going to go there today at all. So we're just trying to isolate the A. So do you guys remember that to type it in the calculator, you can't divide by a sign, you have to do the inverse. So do you remember that you do the inverse sign? Do you remember that? So that's how you come up with an angle. It's a good thing we talked about that. So on your calculator, to do an inverse, you have to type, you just do second. So second sine of 10 divided by 15. You guys remember that?
Yeah.
Coming back slightly. So 41.8, yes. Okay, so that's how you always find angles, is you always do an inverse. Okay, last thing, ready? The last part, they just throw in this super fun stuff. Okay, here's the last scenario. They give you vertices. Anybody see some keys? Keys. There's keys. No keys, sorry. And they ask us to find the sides of the triangle and the angles. So how would you start this?
Plotting the points. You need a triangle first, don't you?
Yeah, let's have a visual. That always seems like a good idea. So let's graph these. So 3, 5 would be right there. So this is the point 3, 5. It's our J. And then negative 3, 2 is right there. Negative 3, 2 is the K. And 5, 1 would land right there. So that's the L. All right, well that's pretty cool.
Wouldn't you use like the points to find how lopsided it is like that?
Uh-huh.
I don't remember how to do that, but I remember you could do that.
You could, yeah. All right, so the first thing that I have to think about is this a right triangle?
We don't know until you figure that out.
Yeah, we can't just be like,
Protractor?
it looks like it. I'm gonna get out my good old compass and measure that sucker out. Well, I guess you could do that. Oh, there you go, Jess.
I don't think you use a
Or protractor. Yes,
Yeah.
sorry, my bad. Wrong word.
It's one of the tools.
One of those two tools that we used. What I'm gonna do is I'm gonna use the idea of well, I don't want to go straight to it. No. Not inverses, but okay. So if we're working with a right angle, what are the two lines that are intersecting going to be? There's a word where two lines meet at a right angle. That's called.
No.
Ooh, this is like a good vocab.
Perpendicular.
There it is. Good. Okay, so we're talking about two lines that are perpendicular. So tell me, what do you know about slopes of perpendicular lines? This goes back into your linear algebra stuff. They're opposites. More than just opposites, because opposite would just be positive and negative. Ooh. Yes, reciprocals. There it is. Good. Okay, so write this down. Perpendicular slopes have negative reciprocals. Or negative, I don't know how we say it. Are negative opposite meaning the same thing. So whatever you want to say. Are negative reciprocals. Okay, so not congruent. No.
Oh, man.
Negative reciprocals. Same slopes as parallel, congruent. Okay, so if I was going to find the slope from K to J, what is my rise over run from K to J? So it goes up 1, 2, 3, and it runs 1, 2, 3, 4, 5, 6. So my slope from K to J is 3, 6. Up 3 over 6. What is my slope from J to L? Down 4, negative 4, over 2. So 3/6 is 1/2. I should have reduced that before. And then this would be, what, negative 2. So are they perpendicular slopes? They are. Okay? So with that in mind, then we know that we can use our Pythagorean's theorem and SOHCAHTOA. Okay? If we didn't know that for sure, we couldn't use those two theorems. Okay. So now we know we have a right triangle. That was step 1. How the heck am I going to find the lengths of these sides? What's that? Ooh, that's slope. You're thinking slope. But there's y's and x's involved.
Is this where like you come into like add 2 points? No.
Ooh. You guys remember the distance formula? Okay, write this down if you don't. This is another one that comes back to haunt you. Like, you learn this one, and then eventually, like 20 years down the road, they're like, okay, find the distance between these 2 points. And you're like, what's that mean? It's actually played straight off of the Pythagorean theorem. Does anybody remember what it is? You're thinking slope. Well, maybe. I don't know. Maybe you're on the right track. You're kind of close. What? Distance. Ooh, that's a whole different ballgame. Distance from 2 points, between 2 points. So you're thinking of like rate times time. Yeah, equals distance. Yeah, that's a different thing. Here, I'll just tell you guys. It's the change in x's squared plus your change in y's.
So that's what we're calculating.
A check mark?
So that's what we're
And then square root.
calculating. That's exactly.
Oh. So this is a big time formula. Yep.
I thought this like the square of the y.
Oh.
Squared and then the square root.
After the square root?
No,
Oh, because you have to add first. You gotta add the numbers before you square root it. Because it doesn't cancel out. That's a very common mistake that people make. Alright, you guys ready for this? Now that we know the distance formula, this is going to be a piece of cake. Alright, which side should we find first? JK? Oh, I knew you were going to say JK. JK. Alright, so from J to K, what's your change in x's? JK. Anybody? Okay. So you could do, if you can go straight to 6, that's fine. That is right. So you could do -3 minus 3, or you could just go straight to 6. I'm alright with that. And what's your change in y's?
2 minus 5.
2 minus 5 squared. So yeah, so you could go 6 squared plus 3 squared, right? So 36 and 36 plus 9 makes, what is that, 41? 40, ooh gosh, bad math. Holy cow, 45. Turn on brain. And I'm going to leave it like that for now. Okay? Even though you could technically break that one to, let's see, square root of 45 is 9 and 5, so 3 square roots of 5. Okay, so today we're going to leave it. Now what side do you want to do? J, L. J, L. J to L. Okay, so what's your change in y's? Or, wait, sorry, change in x's, my bad. Change in x's. 2. Is it okay if I go straight to 2? Or do I need to say how I got 2? It's straightforward? Okay. Please tell me if you want to tell me. Or if that doesn't make sense. Okay, what's your change in y's? From 1 to 5? 4. Do you guys know that this is Pythagorean's theorem?
Yeah.
Isn't that cool? Like, plays 2 parts in this puzzle. Gosh, Pythagorean was such a smart guy. 4 plus 16 makes 20. So square root of 20, which we also could break, but today we're just going to leave. How do you want to find the third side? Pythagorean's theorem. Well, wait, we already were doing Pythagorean's theorem. Just kidding. Just slightly differently. Yeah. Okay, so our third side is what? LK? And that's your hypotenuse, right? So LK squared plus, nope, just kidding, just lying. I was just seeing if you were paying attention. The square root of 20 squared plus the square root of 45 squared, which is just 65 square rooted, right?
Whatever the square root of 65
is the square root of 65. Yeah.
Some number that no one cares about.
What? Clearly someone does. Alright, now we gotta find the angle measures. Perfect, we're almost there. Alright, so which angle do you want to find first? We know J is 90, so we could say J equals 90. We proved that because it was perpendicular. Okay, what about K? How would I find K? So if I go off this one, what do I have to do here? Which theorem do I have to use? Okay, I have to do a SOHCAHTOA. And I can choose which of those I want to do because I have all 3 sides. Which one do you want to do? Sine. I heard a sine, yep. Okay, so we're going to do sine. So we got the sine of K, and sine is opposite over hypotenuse. So the sine will be, for this case, we got JL, which is the square root of 20, over the hypotenuse, which we just found to be the square root of 65. Anybody want to throw that into the calculator? By the way, what are you pushing? for the k. The inverse, right? Inverse for this, so you gotta do second sine of the square root of 20 divided by the square root of 65. What? Because we're looking for an angle, so you have to type it in sine inverse.
So with an angle, you need the inverse.
What's that? Yeah, the only time you use inverse is if you're looking for the angle. If you're looking for a side, then you just use sine or whatever trig function you're using. Anybody? 33.65 degrees. Oh, 9. Thank you. All right, how do we find L? We're almost done. We can do it, guys. Yeah, let's do that. So let's do 180 minus 90 minus 33.69. That would be like, what, 56.31 degrees. So should we do another one of those? Nobody ever says yes to that answer. Huh? Okay. All right.